So here's our first video for the material that's covered on 10/24/18. Just to remind you where we're at here, we're in Chapter 8, and I'm flipping through my notes right now. I don't know if you can hear me turning my pages, but we are in Section 8.3. And where we left off, just to remind you, is we left off with talking about geometric series. And remember that a geometric series was in a special form. We had to start at 0. Now we did do an example the other day where if you don't start at 0 we could still figure out, but we had sum from k equals 0 to infinity of a times r to the k power. And that basically we knew the answer to this, whether it converged, diverged, and what it converged or diverged to, just by knowing what this ratio r was. So if we knew that if the absolute value of r was strictly less than 1, this converged to a over 1 minus r. And then if the absolute value of r is greater than or equal to 1, this simply diverged. So it didn't converge to a number. And so that's where we ended class on Monday. So we're going to continue on. Again, we're in section 8.3. The other thing we need to talk about here in this section is something that's called telescoping series. And telescoping series are a very special case type of series. And in fact, most series that you're going to look at aren't going to be telescoping, but telescoping is a very specific type of series. So let me just give you an example here of a telescoping series so that you can kind of see how we can determine what it goes to, whether it actually converges or diverges, and how we would analyze this. So let's just look at an example. So this is an example of a telescoping series, and you might say, how do I know it's telescoping? Because, well, I know what the problem is. So the way to determine that this is telescoping is that you have to kind of look at the terms here. And what do I mean by look at the terms? Well, if we looked at this here, let's go ahead and write the summation out here. We would have k equals 1, so you'd have 3 over 1 minus 3 over 2, because that's k equals 1. So let me just maybe put down here. So this is for k equals 1. And then plus, I would substitute in k equals 2, so I'd have 3 over 2 minus 3 over 3, and I'm purposely not simplifying things here. So again, this would be for k equals 2, and then plus 3 over 3 minus 3 over 4, and I'll write one more down here, plus 3 over 4 minus 3 over 5, and we're going to go on forever. The dot 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 there, which I almost ran out of room for. And just to be consistent, this would be for k equals 3, and this of course is for k equals 4. And so this is what the sum looks like if we were to try and write out all the terms. Of course we can't write out all the terms, it's infinite. But if we were to try and write these out, this is what we would get. Now, let's just go ahead and see what's happening here and do some of this addition here. So what do we have here? We have 3 over 1 minus 3 over 2 plus 3 over 2. Well, wait a minute. I have minus 3 over 2 plus 3 over 2. So these are just going to cancel each other out. And then I would have minus 3 over 3 plus 3 over 3. Well, wait a minute. I've got the same thing here. I've got a minus 3 over 3 plus a 3 over 3. Those just cancel out. Minus 3 over 4 plus 3 over 4. Oh wait, those cancel out. And then we just have this going on forever. But notice here, this is going to go on forever, but I have a minus 3 over 5, and then we just keep going on forever. But notice here, when I do this, I'm not always getting rid of every term here. When I wrote the first 4 terms down, I got 3 over 1 minus 3 over 2 plus 3 over 2 minus 3 over 3, so on and so on. But I'm left with 3 over 1 minus 3 over 5. So I always have this first kind of minus that last term. So if you want to think about what this is happening is all these middle terms are going to automatically cancel out. Because if I were to write the next term down, if I were to write k equals 5 down, I'd get a plus 3/5 minus a 3/6. So I'd cancel out that negative 3/5. So the way this works here, and it looks a little weird to say it like this, but this is going to be equal to 3 over 1 minus, and it's this term here is the one that never goes away, because that's always going to be there, because it never gets canceled out. But, well, I just have to say, well, it's going to be minus the limit as k goes to infinity of that term. Because the 3 over 1 is not going to go anywhere. It's still there at the beginning, and it's there for forever. But then, as I said, minus, well, I'm always going to have this term that I'm subtracting off, but then I know that term is just going to keep going, k is just going to keep getting bigger. And if I look at this for a second, well, this is hopefully a pretty straightforward one for us to see. This is just going to be 3 minus 0, which is 3. So what did we just show here in this example? Well, the series converges to 3. Now I'm going to just go back here a little bit. This idea right here, this is what makes it telescoping. So you can definitely see how telescoping is a very specialized type of series here, because what's going on is all of these middle terms are canceling each other out. Alright, so let's look at another one here. This is actually problem 49 from your text. And so we've got the sum from k equals 1 to infinity of 1 over k plus 1 times k plus 2. Now, in this section, I mean, it's talking about this being a telescoping, so we know it's telescoping. But if I were to write down what this would be, if I were to write down like k equals 1, I'd have 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5, so on and so on. Well, that doesn't look telescoping. There's no terms that are canceling out in the middle. But we want to remember something that we had done with our integration. It's not integration that we're going to be doing here, but we want to remember a technique that we used with integration, which was partial fraction expansion. And so what we can do is we could write 1 over k plus 1 times k plus 2, and we could write this as equaling a over k plus 1 plus b over k plus 2. And then going ahead and solving this, we'd have 1 is equal to a times k plus 2 plus b times k plus 1. And so what do we get here? Well, we get then that using k equals -1 gets a equaling 1, and using k equals -2 gets us b equals -1. So what we can do, just like we did with the integrals, we can rewrite this series as the sum from k equals 1 to infinity of 1 over k plus 1 minus 1 over k plus 2. So now let's write this series out here and write some terms out, because you have to write the terms out in order to know whether it's telescoping or not. And so what we have here is we'd have 1 over 2 minus 1 over 3. And I'll go ahead and put it in parentheses. Again, this is really just to indicate that, hey, this is when I used k equals 1. But then I'd have plus, for k equals 2, you'd have 1/3 minus 1/4. Another term would be plus 1/4 minus 1/5. And we can see, yes, we are finally getting these middle terms here again to cancel. So we are getting these cancellations going, which means that this is going to equal 1/2 minus the limit as k goes to infinity of 1 over k plus 2, which is 1/2. So this series also converges to 1/2. Now some of you might be saying, well, hey, can't I just evaluate what the first term is and that's then the answer? And the short answer to that is no, because this limit might not go to 0. And let's look at another quick example to illustrate that. So this is not from the textbook, this is just one I'm creating here. So the series 3k minus 3 times the quantity k plus 1. So if we were to write this down here, again, we'll write down some terms here. This would be 3 times 1 minus 3 times 2. And again, this would be for k equals 1. Plus 3 times 2 minus 3 times 3, and that would be for k equals 2. And then I'll write one more term down, 3 times 4, I'm sorry, 3 times 3, not 3.3. I need you guys here to correct all my little silly mistakes that I'm doing here. Minus 3 times 4. Man, I really want to write that as decimal point as opposed to multiplication. 3 times 4. And then we keep going on. Now, notice here we still have this telescoping behavior going on. These 3 times 2's cancel, these 3 times 3's cancel, and the 3 times 4's would cancel as well. So this is going to equal 3 times 1, which of course I know is 3, minus the limit as k goes to infinity of 3 times k plus 1. But wait a minute here. This would be equal 3 minus, this limit is negative infinity. So this actually diverges. And you don't have to say diverges to negative infinity, although that's what it does do. It goes off to negative infinity. But this series diverges. So just because it's telescoping doesn't mean it actually converges. You have to do this. First off, you have to verify that it's telescoping, like I've done on all the examples here, and show that the terms cancel out in the middle. And then evaluate, well, it's the first term minus the limit of the second term, and see what that actually gets you. All right, so that actually wraps us up on section 8.3. We're not done with our videos for Wednesday's class here, but as I mentioned in class, I'm not going to have just one big long video. So we're going to start on the next video, section 8.4.